Hello children, today we are going to continue our topic, that is number system. So far in the number system we have discussed the different types of the numbers, and then we discussed in the exercises the different numerical situations, and also we discussed the how to differentiate the rational and the irrational numbers on the basis of the decimal expansion. And we in the previous exercises we learned to how we can represent the non-terminating repeating numbers in the form p by q as well. That was the important part of the topic as well. And in the earlier classes we discussed how to find the numbers in between the numbers, and what is the relationship between different types of the numbers, and the numbers which are in the radical sign, whether they may be represented on the number line on the basis of different properties, and that all we discussed in the previous lectures. Now today we are going to take our topic forward, and we will be discussing our next exercise, that is exercise number 1.5. Now let us see what are the different numerical questions and that we are going to discuss in this exercise. Let us start with the question number 1 of this exercise. It says, classify the following numbers as rational or irrational numbers. So here we have to classify rational or irrational numbers. That now we are very much aware which types of the numbers can be rational or irrational. These types of the numerical situations we have to deal with here. This is question number 1, and we have to classify this, that is 2 minus under root 5. We have to classify this whether it is a rational or irrational number. So as it is clear that this 2 is a rational number and it is definitely having the terminating decimal expansion, and we have to subtract this with the number under root 5, that is in the radical form. It is an irrational number. There must not be any doubt about this. We have discussed it the number of times on the basis of the decimal expansion. Now as we know, this may be having the decimal expansion 0. I am just giving you the rough idea. There can be so many numbers which will go on up to infinity. I am taking few of the numbers just to give you the idea what will be the result, how we can classify this into the rational or the irrational numbers. Now you can see, if we subtract this again, we will get, it will be 0.4103, so on. Again, after using the subtraction operation between this 2 and the under root 5, you can see we will get the resultant number that is equal to here after performing the subtraction. Now we will get here 0.4103, and this number also you can see by its decimal expansion. From the decimal expansion of this number you can look at this. This is also having the non-terminating, non-repeating decimal expansion, and we know such type of the numbers which have non-terminating and non-repeating decimal expansion will be classified as irrational numbers. So what is the net result of the number 2 minus root 5? Rational subtracted with irrational. So this is always an irrational number. So we can say this is an irrational number. Perhaps you can remember in all the cases where we have the number, where we use the different operations between the rational and the irrational numbers. If we have on one side the rational, and we will use the addition operation, and on the other side we have irrational number. Now the result will always be an irrational number. If we add this number which is having the terminating decimal expansion with the number which is having non-terminating, non-repeating decimal expansion, you will always find it will be an irrational number. Similarly, if we use the second operation, then rational minus irrational number. This also will give us the result as a rational number. Similarly, if we use the multiplication operation between the rational and the irrationals, it will again give us the irrational number. Similarly, if we use the division operation, rational divided by irrational, this will also give the resultant number as a rational number. So, just to remember the idea, you can take numerical examples and you can try on your own as well, whether this thing is correct or not, whether this thing is always true or not. You will find rational plus irrational is irrational, rational minus irrational, irrational, rational multiplied by irrational, it is always irrational. And then if we take the quotient of these, that is division operation, rational divided by the irrational number, it will always be an irrational number. Now, we were discussing the second case here, that is the subtraction operation on rational and the irrational number. And we concluded after performing the subtraction operation, you can see we got the resultant number as an irrational, so we classify this as irrational number. Now, coming to the second one. Now we have the second one, that is 3 plus under root 2 23 subtracted by under root 23. Now first of all, you can remove this bracket, that is 3 plus under root 23 minus under root 23. So in short, we will get this as 3. So here with the resultant number, that is 3. As you know, this can be put in the form P by Q. So we can say the resultant number can be classified as a rational number. Similarly, there are few more examples that we can take. You can try at your home as well. There are a few more examples. Let us take one of the examples that I find it is also the important example from this question. See, what about 2 multiplied by pi? You can see here we have the multiplication operation in between 2 and pi. And we know what about 2? 2 is simply a rational number. And the multiplication, and it has been multiplied by pi. Pi, we know, we have discussed that in detail as well, that pi is an irrational number. So we have here this case, that is third one, rational multiplied by irrational. It will always give us an irrational number. So we can classify this as irrational number. Pi is itself an irrational. If we multiply it by a rational, that's 2. So the result will be always irrational number. So these were some of the numerical examples that were asked in the question number 1 about the classification, how we can classify such type of the numbers. These are the simple examples, and you can try more at your home as well, so as to clear your concept. That will give you the much more idea, much more clearness about the topic. Now we will take question number 2. In this question, the question is about to simplify each of the following expressions. Few of the expressions are there given, then we have to simplify each of them. That will be the question number 2 of this exercise. And see the first one, that is the first part of the question, that is 3 plus under root 3 multiplied by 2 plus root 2. Now let us try to simplify this example. We have to perform simply here the multiplication operation. is a simple multiplication operation that you have been doing from the lower classes. In the lower class you have done as well. So first of all, it will be 3 has to be multiplied by 2. So it will be 3 2s are 6, and 3 with under root 2, it will be 3 under root 2. Then under root 3 has to be multiplied. We have to multiply by under root 3, so it will be 2 root 3. And then we have under root 3 multiplied by under root 2. Further, we can write it like this: 6 plus 3 root 2, it will be unchanged, then 2 root 3. Here we cannot add these two different quantities. It is the radicand is different. Here the radicand is 2, that means the number which is in the radical form, that is 2, and here it is 3. And then we have to simply multiply. We can multiply them together, that is, it will be root of 6. So this is the resultant expression after simplifying 3 plus root 3 with 2 under root 2. Now what is the next part of the same question? That is 3 plus root 3 has to be multiplied by 3 minus root 3. So in this case you can see we have, it may be, it's the numerical problem here which is given. We can say it is of the form of a plus b, this can be treated as b, and a minus b, and you know one of the simple identity, this can be taken as b. 3 can be treated as a, and under root 3 can be treated as b, and we know the result, that is a plus b multiplied by a minus b. We have the identity that is equal to a square minus b square. So we can write it 3 square minus root 3 square. So that will be equal to 9, and square and root goes, it will be 3. Then the resultant value is 6. So after multiplication we had the identity a square minus b square, that can be applied here, you can see, and then performing the simple operations of the subtraction, we get the result as 6. Similarly, some of the other examples can be solved like this. Let us take the third one, that is root 5 plus root 2, and it is whole square. Again you can see it is of the form of a plus b whole square, and you know this result, that is equal to a square plus b square plus 2ab. This is also one of the identity you may be knowing. So we can apply directly here in our case. So it will be a square, then b square plus 2 times root 5 multiplied by root 2, 2ab. So here we have under root 5 whole square. So we can write this as square and root we can cancel, so cancel it out. So it will be 5. Again here it will be 2, and we can multiply these two radicands, and the result will be 10. Then 5 plus 2, after addition it will be 7, and 2 root 10 will be as it is, and this is the result of the given expression, that is under root 5 plus under root 2. We applied here the identity, that is a plus b whole square. That is very simple now, you can see, and after performing this operation we got it 5 here, 2, and then we have to add it with 2 root 2 or 2 root 10. Then after performing the addition operation again in the next step, 5 plus 10, it will be equal to 7 plus 2 root 10. This is the net result of this expression. Now now we are going to discuss the important part of the topic, that is how we can represent the numbers which are in the radical form on the number line. So far we have discussed few of the numbers like root 2 and root 5, and we discussed the Pythagoras method as well in those numerical examples. Now we are going to discuss the general method that will encompass all the the numbers which are in the radical form, which can be represented with the help of the method that we are going to discuss. The question is, it is question number 4 actually, that is root of 9.3, that we have to represent on the number line. And this question can be treated as important question from the examination point of view. You can see the previous sample papers as well, that these types of the questions have been repeated number of times in the examinations. So treat this question as very important from the examination point of view, and this is very important part of the topic, that is our number system. Now if we have any of the number, let us suppose, before going in detail for discussing the under root 9.3, let us see first of all how we can represent a number that will be of this form, under root x. This x can be any number. If we understand this, how this under root x can be represented on the number line, that means then it will be very easy for us to represent all the numbers which are in the radical sign, to represent them on the number line, be it under root 9.3, be it 7.3, be it 6.5, some other numbers in short. So we are going to first discuss the general method. What is the general method? How we can represent this if a number x is in the radical sign, how that can be represented on the number line. This general method will apply to then all the types of the numerical examples. So let us try to understand this, the radical, the number x which is in the radical form. First of all, let us see the geometrical interpretation of it. Then we are going to give the mathematical justification to the result, that is under root x. Now let us first try to the geometrical point of view how we can represent this on the number line. First of all, what we have to do, we have to take a line segment. We'll take a line segment, name this as AB. AB. Now this AB is to be taken of the length of the required number, that is x here. X can be any number, it can be 5, it can be 6, it can be 9.3 as well. So draw a line segment AB equal to x units of the length. Unit can vary, and then what we have to do, we have to extend this on the right side. Extend this line segment, that AB, up to the point C. And how much we have to extend it? 1 unit length. Then we got now the line segment AC. Now this line segment AC is of the length x plus 1. So if we say this is equal to x plus 1, that is line segment AC after adding 1 unit of length. Now our next step will be, we have to draw the perpendicular bisector of this line segment, that is AC now here. How to draw the perpendicular bisector of this line segment, that we have been doing perhaps from this class 6, how to draw the perpendicular bisector of any of the line segment. What we do there, we place the compass at the two extremes. Here the two extremes that we are going to take is A and C. First of all, we will take A as center, and how much we have to take the radius, that is more than half. Let us suppose this is the half of the line segment. We have to open the compass, we have to take the radius more than half of that line segment, that is more than half of AC. We will take A as center and draw an arc. again from this side as well, as you are aware how to draw the perpendicular bisector. Now with the same radius, we'll place the compass at point C. Now what we will write? With C as center and same radius, draw another arcs on the either side of AC. First of all, what we did, with A as center and radius equal to more than half of AC, draw arcs on either side of AC. And again with C as center and same radius, draw another two arcs intersecting the two previous arcs. And then what we have to do, we have to join so as to get the perpendicular bisector. Now this will be the bisector of the line segment AC. Name this as point O. So O will be simply the midpoint of AC. It will divide AC in two equal parts, AO equal to OC. So the total length that we know, AC is equal to x plus 1, and from O to C it will be now half of the length of AC, that is x plus 1 divided by 2. Similarly, OA will be of the length x plus 1 divided by 2. Now it is clear now, very simple. Now what will be our next step? We have to take O as center and radius equal to OA or OC. That is same thing. Draw a semicircle. With O as center and radius equal to OA or AC, we have to draw a semicircle. Definitely that will touch at two extremes, that is A and C. So we have drawn a semicircle now. Our next point will be now at point B, we have to draw the perpendicular, that is altitude. We have to draw at point B, and we can draw the altitude with the help of compass as well, as you know, or you can take the help of the protractor as well. Here we have to draw the perpendicular 90. Now you can see the perpendicular that we draw at point B, it touches this semicircle at some point. Name this as point D. Now we can extend this line, that is AC, on the right side. This is of the from B to C, starting from the B, it is of the unit length, that is 1 up to C. Similarly, we can mark here some other points. B, C, D, it can be taken as E. Similarly, F. Similarly, we can take some other points, that is G. Now we are extending this line and taking the equal widths, that's of the unit length. We can say at point C it is of the unit length, and up to point E it will be of the length 2, then 3 and 4 and so on. As in the case of the number line, we are just using the idea of the number line here. Starting from point B, this can be taken as 0 of the number line, then 1, 2, 3, so on, as you are aware. Now what will be our next step? We have to now take B as center. With B as center and radius equal to BD, then we have to draw an arc. And you can see, after drawing an arc, this I am giving you the rough idea to how we can geometrically represent root of x on the number line, and this length, that is BD, is of the root x. And what we are going to actually represent, simply we want to get the length root of x. So now we have got BD equal to the root of x, that is of the length of root of x. Now we take B as center and radius equal to BD, draw an arc that will touch the number line at some point, and then this point where this arc intersects the number line, this represents root of x. So this is geometrically how we can represent this root of x on the number line. We have to take the mathematical justification as well for this, how this BD is of the length of root of x. But let us try to understand first. Let us recall it once again what we did so far in the geometrical presentation of under root of x. What we did first, we take line segment AB of the length x, then extend it on the right side up to C of the unit length, 1 unit length. Now what we did further, we draw the perpendicular bisector of AC, you can see, and we got O as the bisector of this line segment AC. Now with O as center and radius equal to OA or OC, we draw a semicircle that touches it at two extremes, that is A and C. Now at point B, we draw BD perpendicular on this AC. Now after taking, now our next step will be now how to, this BD is of the length of the root of x. Now with B as center and radius equal to BD, draw an arc that will touch the number line at some point. This point where this arc touches the number line is simply the root of x. Now let us try to analyze this concept mathematically. What is the mathematical justification for this, whether BD is really equal to the length of root of x? For that, we have to take the mathematical proof. So there are one, that is the geometrical interpretation. Now we have to take the mathematical justification for this step. So here we can write simply, here OA, OC and OD, you can see these are all the same length, that is OA is the radius, OC and OD is also the radius of the semicircle. So A plus C, we know it is x plus 1. So half of that will be x plus 1 divided by 2. So all the, whether it is, so we can write here OA equal to OC equal to OD. They are equal to x plus 1 by 2. And there is no doubt about that. This point, it is clear from the figure. Now we actually want to get the value of this x, value of this BD. That is the question mark for us. And you can see we got a triangle, right triangle OBD here. We know the longest side, that is OD, that is equal to hypotenuse, that is x plus 1 by 2. And OB, now OB is equal to, can we find the length of OB from this figure? You can see OB is simply OC minus BC. So that is equal to OC. OC we know that is x plus 1 divided by 2. And what about BC? BC, as we extended the number line AB on the right side of the unit length. So the length of the BC can be taken as 1. Now we can take, we can simplify this like this. It will be x plus 1. It will be then minus 2 divided by 2. So in short, this will be equal to x minus 1 divided by 2. Now we have got a right triangle OBD in which we know the hypotenuse, that is x plus 1 by 2, and what is the base, that is x minus 1 by 2. Now we know the two sides, we can get third side, that is BD. Now we can write, if we use the Pythagoras theorem in this triangle, hypotenuse square equal to base square plus perpendicular square. Using that theorem, we can find the value of BD. BD is simply equal to OD minus OB. OD minus OB, which can be further written as OD. What is the value of OD? That we know OD is equal to x plus 1 by 2. And then the value of OB. OB, you can see that is after subtracting BC from OC, we got OB, that is x minus 1 by 2. So we can use here simply x minus 1 by 2. And you know, we in case of the Pythagoras theorem, we take square of the sides, that is BD square, OD square minus OB square. So simply we have to use here also the square. Now we can simplify this further. You can see it will be, this is x plus 1 divided by 2 whole square. So this square is on the numerical, the numerator and the denominator as well. Likewise in the second term as well. So we can take this as, it will be a square plus b square plus 2ab, that is 2x, and likewise here, and in the denominator we have this is equal to 4. Similarly, we can use first the formula, that is a minus b whole square, that is a square plus b square minus ab, that is 2x whole divided by 4. Now we can take 4 as LCM. 4 can be taken as LCM, and then we have in the numerator x square plus 1 plus 2x, then minus x square minus 1 plus 2x. So the resultant value will be x square, it is plus and minus. Similarly, we have 1, it is plus and minus. 2x plus 2x, this will be equal to 4x whole divided by 4. 4 and 4, we can make some cancellations, and this will be equal to x. In short, BD will be equal to, we can write BD will be equal to, we can write BD equal to under root of x. So we have given here the mathematical justification as well to our step, that whether this BD is of the length of root of x. So definitely after performing the using the PGT in simply in triangle OBD, that's a right triangle, we got BD is of the length of root of x. So this is the mathematical proof. So if the same question is asked in the examination, first of all what you have to do, you have to take the length of under root, that is 9.3. We take here the general example, that is root, that is of the x, and then the same method you have to follow on this example. You have to take this AB as 9.3, extend on the right side of the 1 unit length, that will be the total length in our case will be 10.3. Then we have to find the perpendicular bisector, that is the O will be taken as the perpendicular bisector of AC. Then draw the semicircle, like in our case, in case of the root x. Root x, simply it is a general article for to represent this on the number line, and with the help of this, as we discussed, that all the other numerical examples can be solved, and the procedure will be like this. Similarly, you can follow the mathematical proof same in case of the root of x. Now simply you have to replace here x with 9.3. This has to be replaced with 9.3, and then in this way we can represent this on the number line. So this is how, this was the very important part of our this number system. This question is very important from the examination point of view, and there can be values can be changed in the examination. It may be 9.3, 6.3 as we discussed. Now we are going to take the next question, that is question number 5 of this exercise. That is also very important. That is based on the rationalization of the denominators. So the question has been asked simply, rationalize the denominators of the following. First one, now let us see how we can rationalize the denominator. Root of 7. In this case, what we have to do to rationalize the denominator, that means we have to remove this radical sign in the denominator. So this root form has to be removed in the denominator. So in this case, how we can represent? How we can remove this radical sign in the denominator? If we multiply this in the numerator and the denominator by the same number, that is root of 7. In this way, we can get a perfect square. So as if we get when we get a perfect square, we can remove this radical sign in the denominator. So for that, what we do, we multiply it in the numerator and the denominator by the same number, that is root 7, which will be further equal to root 7 divided by root 7 whole square, and in this case square and root will go, so it will be root 7 divided by 7. So the net value we got here, that is under root 7 by 7. Now the radical sign is in the numerator. This has been removed in the denominator. So this is how we can rationalize the denominator. Second part, that is 1 divided by under root 7 minus under root 6. Now we have, in the first case we are having the one term here. Now here we have two terms. How to rationalize such type of the denominator? So we have to multiply it in the numerator and the denominator. Remember, in this case, when we have the two terms in the denominator, we have to multiply in the numerator and the denominator by its conjugate. Conjugate means the sign which has been used in between these two radicals, that is under root 7 minus root 6. We have to replace it by its conjugate, that is the addition operation. Now 1 multiply this multiplied by under root 7 plus under root 6, it will be root 7 plus root of 6. And then you can see in the denominator we have again, we can use the identity here. It is of the form a minus b multiplied by a plus b. So simply you know that that is equal to a square minus b square. So that will be equal to root of 7 plus root of 6 whole divided by 7 minus 6. So that is equal to root 7 plus root 6. This is how we can rationalize the denominator when we have the terms, when we have the two terms. Some other parts are of this form are discussed, that is part number 3 and part number 4. That will be you can try this at home so as to clear this concept. And then some other examples that may be given to you as an assignment, that we will be discussing in the normal classrooms as well. What are the some other situations where we have to discuss when we have in the denominator the three terms. In that case as well, that may be of the questions of the higher order thinking that will be discussing in the classroom, normal classroom situations as well. So far in our book, this topic has been limited up to the two terms in the denominator. So few more examples you can try at your home. Now what is our next, that is the last topic of this chapter, that's the number system. We will be discussing here laws of exponents. These laws of exponents you have been discussing so far in previous, that is class 8th as well, you have discussed. But in class 9th and in class 8th, what is the point of difference? There we have also discussed the laws of exponents. But in class 8th, remember that the laws of exponents we have discussed on the while using the base and the powers as the natural numbers. Here we will be discussing the numbers which are real numbers and the rational numbers as well. That is the only difference that we discussed in the previous class and in class 9. In class 8, we discussed that laws of exponents on the natural numbers. Here we have to discuss it on the real and the rational numbers. Real numbers as the base and the rational number as the powers. That means if a greater than 0 is any of the real number and p comma q, they belong to rational numbers, rational. So what are the different laws that we call as the laws of exponents, or in other words we can say laws of the radicals as well. The first one is, if in case of the multiplication, if we have number a to the power p multiplied by a raised power q, so this is always equal to, remember, when bases are same, here a greater than 0 is a real number, is any of the real number, and p comma q, they belong to the rationals. In this case, if we use the multiplication operation, when bases are same, powers will be added in that case, p plus q. Second one is, if we have a to the power p and then we have the whole power q, then these two powers, that is p and q, will be multiplied. So we will get a raised to the power pq. This is the second one. Then third, in case we use the quotient of the numbers, that is the division operation, a raised power p and a raised power q. In this case, we have to remember that these powers will be subtracted. So it will be a raised power p minus q. Then fourth one, if we have the two real numbers, if we have two real numbers, a raised to the power p and b raised to the power p. In the first three cases, first three laws, we used a as the base and p and q as the powers. Now if we have two numbers as base, a raised to the power p, b raised to the power p. Now in that case, these two bases will be multiplied, that is a multiplied by b and whole power p. Similarly, we have one more, anything raised to the power 0, that you have been discussing number of times, that is always equal to 1. These are the basic laws of exponents that we will be using in the numerical problems. Now it is very simple. So first one, we have to remember, that is, in case of the multiplication, if bases are same, powers will be added, and if a situation will be like the second one, a raised to the power p and then whole power q, these two powers will be multiplied, and then if we have the quotient of the number, that is a raised to the power p divided by a raised to the power q, then in that case the powers will be subtracted. And if we have a situation like this where we have the two bases, two different bases but same power, in that case the bases will be multiplied and then this power can be taken as power for the both the numbers. Then we have the last one, anything raised to the power 0, that is always equal to 1. Now let us take the simple exercise number 1.6, that will clear us the concept about how we can use the laws of exponents if we are given the different numerical problems. The first one, it is 64 raised to the power 1 by 2. You can factorize first 64, or also this can be factorized at 8 square. In terms of the 2's as well, you can try, but we have 64 as a square of some number, that is 8 whole power 1 by 2, and in this case, you can see from the laws that we discussed, it is of the form a raised power p whole raised power q. Now these two powers will be multiplied. When we multiply these two powers, this and 2 will get cancelled, so the result will be 8. Similarly, we can take one more example. That is, let us take third part. That is, we have 125 raised to the power 1 by 3. This 125 can also be factorized as 5 raised power 3 whole multiplied by 1 by 3. That 3 and 3 will be cancelled here, so the result will be 5. Now, question number 2. Now we have to find 9 raised to the power 3 by 2. This we know, this can be written as 3 square. 9 can be written as 3 square and whole power 3 by 2. This 2 and 2, we can cancel it out, and 3 raised power 3, that will be equal to 3 multiplied by 3 multiplied by 3, that is equal to, in our case, 3 3s are 9, 3s are 27. And then we have fourth one. This was the first part, and the fourth part with the negative power. Let us see how we can solve that. That is 125 raised power minus 1 by 3. So we can write it like this: 1 divided by 125 if we have to make the power positive. Now again the situation arises like of this form: 125 raised to the power 1 by 3. So we can further write it like this. It can be 1 divided by 5 raised power 3 whole raised power 1 by 3. 3 and 3 we can cancel, so this can be written as 1 by 5. Or this can be further changed like this: 5 raised power minus 1 as well. Then we can take a few more examples of the question number 3. Very simple. Let us take the first one. In this case, we have to simplify 2 raised to the power 2 by 3, then multiplied by 2 raised to the power 1 by 5. So in this case, you can see the first law. From the laws of the exponents, when bases are same, powers will be added. So bases same, powers will be added. It is 2 by 3 plus 1 by 5. Now you can simply we can simply take the power of the LCM of the powers. So it will be 10 plus 3 by 15. So that is equal to 2 raised to the power 13 by 15. In this way, there are some other examples which you can solve on your own, and you can try some other examples from some other reference books as well to clear the concept. That will give us the much better idea as well about how to use the laws of exponents on the different numerical examples that are asked. And in this way, we have reached up to exercise 1.6. That is actually the last exercise of our topic number system. So from starting to end, we learned here the classification of the numbers, how to represent the rational and the irrational numbers. Rational we had discussed in the previous classes as well, but here also we can take in the combined form the rational and the irrational. As we are discussing here mostly the real numbers on the number line as well, and we learned the most important, that is how to represent in the radical sign the different numbers on the number line. Today we learned also the general method of representation of such type of the numbers, and how to rationalize the numbers with the different denominators. It may be having the one term, it may be having the two terms, and some other situation as well that can be dealt in the classroom as well. And also we discussed the laws of exponents here, and we took some of the numerical examples where we can use the laws of exponents. In this way, we have cleared all the topics. We have covered all the topics that were in our first chapter, that's number system. So I as a teacher can advise you that not only to rely on what we saw in the video, but you can try some more examples at your home, because as you know, mathematics is a beautiful subject. It is the very much interesting subject, but if it can be taken in the right direction, it has to be, justice has to be done with the subject. I can advise you at least give 1 hour daily to your subject, that's mathematics, and practice more and more examples so as to clear your previous concepts. And in this way, you can make your subject strong, and you will in future love to have mathematics as your subject. Thank you very much for today's lecture.